This will be a quick lesson on graphing and using error bars. Previously, you might have learned how to draw a best fit line through your data points by using a ruler. For this lesson, we're going to help us facilitate this process by adding our errors to each of our data points. Our error bars will then represent the uncertainty of your data points. Below, we have an example. And we're going to graph the following. We're going to graph x as 1,000.0 plus minus 5 grams. And we're going to graph in the y-axis 0.94 plus minus 2 seconds. This is just one data point, and I'm going to show us how to draw the error bars accordingly. First, let's plot 1,000 grams and 0.94 seconds onto our graph. I'm going to give you a chance to do that and compare your answer with mine. And this will be a good time to pause your video. This is my graph that I have. Yours may look something similar, but you do want to make sure you have these features. A title of your graph, a descriptive title, making sure it's underlined, making sure you have a labeled x-axis, making sure you have a labeled y-axis. I've decided to make every one of my gradients at 100 grams, so 0.1 kilograms, so I use kilograms instead of grams for my bottom, which is probably you should be doing with your graph later on as well if you haven't already made it. As for the period, I made every single gradient 0.1 of a second, so that my data point is going to be right smack in the middle. Okay, drawing these error bars, let's start with the x. Let's start with the x-axis. We're going to look for plus minus 0.5 of a gram. 0.5 of a gram. So that is very, very tiny on our graph. We barely will be able to see that because one gradient is 100 grams. That means 0.5 of a gram is barely even noticeable. So that's kind of even smaller than that. I have to draw these tiny error bars. So, such as these might not be visible. And if they're not visible on your graph, you can have a liner underneath your graph, like a caption saying how the uncertainty or the error is not visible. But that's just for our x. What about for our y? Okay, our y is plus minus 2 seconds. We know that each gradient is 1.1 of a second. So in order to draw 2.2, we're going to look at 2 lengths wide. So we have 1 length wide, 2 lengths wide up. And then we're looking at 0.2 down from this data point. So we're looking at 1.1, 0.2. So that's what our error bar was going to look like. If you want to, you can even take a look at the box that these errors create. So if we want to do that, let's zoom in again. If we take a look at this box, it kind of shades in this area over here. So these error bars shade in this area over here. So as wide as your x error bar and as long as your y error bar. So it encapsulates a box. The box that's created due to your error bars represent the possibility of your data point being anywhere within that box. Why is that important for drawing our slope later on? Imagine you have many of these. Imagine you have many of these, like this. And such like this. Then when you draw your best fit line, then you want to make sure that your best fit line goes through within all of these error bars. Okay? So kind of like this. Or maybe if you're doing if it's a straight line, then you use your ruler, making sure your ruler crosses through within all these error bars as best you can. So that's the benefit of error bars when you are drawing your slope. Hope you enjoyed this video, And we'll tune in into the next one. Bye now.